Okay, so R23 basically would tell you what is the relationship between x2 and x3, what is the amount of variation in one variable that is being explained by the other variable. Alright, so after that, you might also have variables like R. So R23 square would be, so you remember that when I wrote R square, I don't know, my computer isn't working properly today. So R square I know was nothing but summation yi xi upon summation xi square, and this was square. So we had done this. So now what am I doing is, this is the new formula for R23. So it's summation y x2y x3i whole square upon summation x2i square summation x3i square. Just make sure that you understand that all of this is actually in the deviation form. So the properties are that summation ui hat has to be equal to 0, right? So mean of summation yi hat is equal to the mean of actual yi. So you should remember that yi hat is only the estimated value of e of y given x2y x3i, whereas this actual yi is actually yi hat plus ui, and obviously the mean has to be equal. So the residual sum, so basically we have done all these properties for classical linear regression model 2 variable case. I'm just extending the same properties to classical linear regression model of 3 variable case. So residual ui hat is uncorrelated with x2y and x3i. As R23 increases towards 1, the variance of beta 2 hat and beta 3 hat increases. So we have already derived what beta 2 hat and beta 3 hat basically are. So now giving you the formula for variance, beta 2 hat has this variance, and if you replace x2i with x3i, you would basically get the variance of beta 3 hat. So you can clearly see that as R23 increases from 0 to 1, the variance of beta 2 and beta 3. So the variance of beta 2 hat and beta 3 hat also increases. So now coming to this, so the variance is this. So you can see that, and by the way, this is known as 1 upon 1 minus R23 square is known as VIF, which is the inflating factor. So it actually inflates the variance, as you can clearly see, because as R23 increases, the variance also increases. So it actually brings in inflation in the variance, or increases the variance, right? So if I have yi is equal to beta 1 plus beta 2 hat x2y plus beta 3 hat x3i plus ui, and then if I find out the mean, I get this, and from here I know that this is 0. So if I can subtract the two things out, I can find everything in the deviation form. I can get in the deviation form small yi is equal to beta 2 hat x small x2i plus beta 3 hat small x3i plus ui hat. Now I can all that I want to do is that I have to square both sides and sum. So after simplification you will get this. So you will get summation yi square is equal to beta 2 hat summation yi x2i plus beta 3 hat summation yi x3i plus ui hat square. So this thing is the explained sum of square, this is the residual sum of square, and this is the total sum of square. So now in a 3 variable case, I introduce capital R square, which is ESS by TSS. So it tells you what is the variation in y, which is jointly explained due to the variation in x. So basically what R square tells you, suppose if I say R square is 0.95, then it says 95% of the variation in y is jointly explained due to the variation in x23 and x3. So x2 and x3 jointly explain 95% of the variation in y. Okay, so note, remember you cannot compare R square of two models unless its y variable is in the same form. So for example, I have, so basically you should remember first